So in today's video, we're going to go ahead and delve into the definition of concavity. And so here we kind of have two definitions of concavity. We have concave up and we have concave down, or concave upwards and concave downwards. And I mean, there's no real way to kind of define it, but the way that I like to think about it is that whenever we're concave up, then our graph has this sort of upward U shape. And whenever we're concave down, then our graph has this sort of downward U shape. And so I'm going to show you kind of what I mean by that in this small little graph over here. And so if we were to illustrate what concave up may look like, it may look something like this, right? Almost like an upwards parabola. So this would be concave up. And if we were to be concave downwards, then it's going to be the sort of downwards, sort of kind of like they call it like a cap shape. And that could kind of look like a downwards parabola, right? A parabola opening up downwards. This would be concave down. And the way that we can mathematically determine when a function is concave up or concave down is through the second derivative. And later on, we're going to delve into the second derivative test. But essentially, if our second derivative is negative, so if f double prime is, actually let's start with positive. If f double prime is positive, right? If f double prime is greater than 0, then we are concave up and we have this sort of U shape, that's opening upwards. So in this case, we could say that f prime prime would be greater than 0. And whenever f double prime is less than 0, so whenever our second derivative is negative, then we can say that we are concave down, right? And so in this case, we would be concave down and our second derivative would be less than 0, right? And whenever f double prime is equal to 0, then we have a special case. We'll delve into that a little bit later. But now what I'm going to do is I'm going to see kind of how we can analyze the concavity and the manner in which a function is increasing or decreasing just graphically. And later on, we will delve into how to actually determine concavity mathematically using inflection points and the second derivative test and everything. And so let's go ahead and take a look at that. So if we were to look at this graph over here, we can mark the different points at which we are concave up and concave down, right? And so, for example, right over here, if we were to take this point right over here, we can say that we are kind of concave down within a little neighborhood of this point, right? So, or let me pick a different point. Let's say we're at this point right over here. Here we would be concave down, or sorry, concave up. And why are we concave up? Well, we have this sort of shape in which we're opening upwards, right? Because if you look at it, we match this sort of upwards parabola shape that we established right over here. And so we can say that our second derivative is positive over here. So at this point, we know that f double prime is going to be greater than 0. What can we say about f prime at this point, though? Well, at this point, it looks like our tangent line may be approximated to look something like this, right? And so we know that f prime, right, the slope of our tangent line is going to be negative, right? So f prime would be less than 0 at this point, but f double prime would be greater than 0 because we are concave up. Let's say we pick this point right over here. At this point, what can we say about the first and second derivative? Well, in terms of the first derivative, it looks as though the slope of our tangent line is positive, right? So right over here, we can say that f prime is going to be greater than 0, right? Because our function is increasing. But what about concavity? Well, right over here within this region, it seems as though here we are concave down, right? Because our graph is kind of opening downwards at this point. And because of the fact that we're concave down at that point, this tells us that our second derivative is going to be negative. And so we can get some information about our function just looking at its concavity. We don't even know what this function is. We don't even care about what the value of our function is at this point. All that we care about is just analyzing its concavity and the fact that it's increasing to determine that the first derivative is positive at this point and the second derivative is negative. If we took this point, for example, as well, here it looks like the slope of our tangent line is negative. So here f prime would be less than 0, and we are still concave down at this point, and so we could also say that f double prime is going to be less than 0. If we took a look at maybe this point right over here, then again, here the slope of our tangent line looks to be positive, right? It looks like our tangent line, or our function seems to be increasing here, and we can approximate the tangent line to look something like that. And we are concave up at this point. Why are we concave up? Well, we have this sort of opening upward shape that we get when we have an upwards concavity. And so at this particular point, we could say that f prime is going to be positive, right, because our function is increasing, the slope of our tangent line is positive. And we know that f double prime is also positive because at this kind of point here, we are concave. Here we are concave up, right? And sometimes you'll actually see these two symbols used to represent concavity. So like the U shape and it's like the union and intersect shape if you've ever taken set theory. And then let's take a look at one final point, just to get a little bit more practice. At this point right over here, it looks as though we are concave down, and it seems as though our tangent line may be approximated to look something like this. And so the slope of our tangent line is negative, so f prime is less than 0. And it seems as though we are concave down, so f double prime is going to be also less than 0. And so we can say that we're concave down within this region here. So this is concave down, right? And so this is just a very, very basic introduction to concavity and how we can correlate it to the second derivative. So we just have a couple of really just two things that we need to know for the time being, is that whenever our second derivative is greater than 0, so whenever our second derivative is positive, then we are concave up and we have this sort of upwards U shape, kind of comparable to a parabola where our leading coefficient is greater than 0. And whenever f double prime is negative or less than 0, then we are concave down and we're going to have this sort of upside down U shape, kind of similar to a parabola in which the leading coefficient is less than 0, right? And so this is how we can use concavity in order to actually analyze the sign of a function's derivative.